Hello, everyone, and welcome to the Geostrategic Podcast. Thank you for watching or listening to the podcast. The U.S. Air Force is spending $1.7 billion upgrading the F-35, but there's one massive problem. Some of these stealth fighters may actually fly without radars, and according to pilots, that could make them completely non-deployable in real combat. So how did America's most advanced fighter jet end up in this situation? Is the new APG-85 radar a revolutionary leap in air combat, or a billion-dollar mistake? And what happens if war breaks out before the upgrade is ready? Stick around, because the details are far more shocking than most people realize. And before we begin, I want your opinion. Would you trust an F-35 flying without a radar in combat? Could this become a serious national security problem? Drop your thoughts in the comments. I read every one of them. And if you enjoy deep defense analysis like this, hit like, subscribe, and share this video so more people can join the discussion.
Right. So to set the mission for our deep dive today, we really need to bypass the basic talking points. We're going to quickly and precisely break down the geostrategic implications of this whole radar upgrade gap based on the latest info.
Yeah, definitely.
Because the goal here is to explore that friction between, digital ambition and physical reality. We have to look at how literal hardware limitations are bottlenecking America's premier stealth fighter fleet.
Okay, let's unpack this. Because to the average person, upgrading a radar on a modern fighter jet sounds like, swapping out a graphics card in a gaming PC.
Right, you'd think so.
Yeah, you just unplug the old one, you plug the new one in, update the drivers, and you're good to go. But looking at the latest updates, this is anything but plug and play. It's like buying a cutting-edge processor that fundamentally doesn't fit your computer's motherboard, but on a multi-million-dollar scale.
That is exactly the engineering nightmare playing out right now. You cannot simply slide new APG-85 radar into the physical cavity left by the current APG-81.
Because the mountings are different.
Exactly. The structural skeleton of the nose, what engineers call the bulkhead, it just doesn't align with the new radar's mounting points. And, you can't just drill new holes into a stealth fighter.
Right, because the stealth coating.
Yeah, every single millimeter of that airframe is mathematically contoured to deflect enemy radar waves. If you alter the internal structure improperly, you risk compromising the exterior stealth capability.
I have to stop you there because the scale of this oversight seems staggering. We aren't talking about like a dozen prototype jets here.
No, not at all.
If you're a taxpayer listening to this, the numbers are alarming. We are looking at 181 F-35As, specifically from production lot 17 and prior, that need this physical retrofit. That is a massive chunk of our frontline fleet.
It is substantial, yeah. To fix this, the Air Force has been engineering what they call a dual-mount bulkhead.
A dual-mount bulkhead.
Right. Think of it as a universal structural adapter that can securely hold either the old radar or the new one without ruining the aircraft's physical integrity.
Okay, that sounds like a logical fix.
It is, but the problem is the timeline. Developing, testing, and fielding that new structural skeleton alone is projected to take 2 entire years.
2 years. Just to figure out how to bolt the thing into the plane, which forces an incredibly uncomfortable question. I mean, you can't just ground 181 of your most advanced stealth fighters for 24 months.
No, you absolutely can't.
So how is the Air Force actually keeping these things in the sky while they wait for the adapter? And I have to be honest, when I read the latest news on this workaround, my jaw hit the floor.
It's quite the workaround.
They are flying these $80 million stealth fighters with literal ballast, just dead lead weight stuffed into the nose where the radar is supposed to be.
I know it sounds completely archaic, placing lead weights inside a 5th-generation fighter, but it is a strict aerodynamic necessity.
It is the balance.
Precisely. The F-35 is a highly tuned, aerodynamically unstable airframe. It relies on computers to keep it flying straight. The missing APG-81 radar weighs hundreds of pounds. If you fly that jet with an empty cavity in the nose, the center of gravity shifts drastically backward. The aircraft would literally become unflyable. So the ballast replaces the mass of the missing radar just to keep the jet's physics balanced.
Okay, so physically the plane can fly, but tactically? This is where the logic seems to completely fall apart for me.
How so?
Well, the proposed execution is to data link these radarless jets with an older F-35 that still has its radar intact. So you have a 4-ship formation. 3 jets have dead weight in the nose. 1 jet has a working radar, and they are spread out across dozens of miles of airspace.
Right.
Wait, so we have a scenario where 3 out of 4 of our most advanced stealth fighters are essentially flying blind and relying on 1 jet's eyes. It's like sending 4 SWAT officers into a pitch-black warehouse. but only the guy in the very back has night vision goggles, and he has to verbally text the other three where the armed suspects are.
That's a great analogy, actually.
But how does that possibly work in a contested environment where milliseconds matter?
It doesn't work perfectly, and that is precisely why pilots are raising the alarm. Your SWAT analogy captures the latency issue perfectly. The whole concept of the F-35 is built on something called sensor fusion.
Right, where the computer does the heavy lifting.
Exactly. The onboard computer acts as a central brain. It takes data from the radar, the infrared cameras, the electronic warfare sensors, and it synthesizes it all into one clean, unified picture on the pilot's visor.
So it gives them a sort of God's eye view.
Yes. But when you strip the radar out of 3 of those jets, you sever a massive chunk of that sensory input. Now, those blind jets are forced to rely entirely on a data link beaming information from their wingman, who, like you said, might be 30 miles away.
And there's a delay.
Right. Because the jets are separated by distance, the data link takes a fraction of a second to beam that radar picture over. And in the world of modern air combat, a fraction of a second is an eternity.
Because everyone is moving at the speed of sound.
Precisely. At Mach 1, an enemy jet is traveling roughly 1,000 feet every second. So the wingman's radar spots the enemy and data links the coordinates. But because of that split-second delay, by the time the data reaches the blind jet, the enemy has already moved.
Oh, wow. So the data is instantly outdated.
Yes. Meanwhile, the blind jet's own localized infrared sensors pick up the heat signature of the enemy in its new real-time location.
Oh, I see where this is going.
The F-35's computer tries to fuse these 2 pieces of data, but it can't reconcile the time gap. It thinks there are 2 different heat signatures in 2 different places.
So it draws 2 distinct enemy planes on the pilot's screen. And that's the ghosting effect we keep hearing about.
Exactly.
The computer is essentially hallucinating a second target because the math doesn't add up. Imagine being a pilot in a high-G dogfight, adrenaline pumping, and suddenly your helmet display tells you there are 3 enemy fighters closing in on you when there's actually only 1.
It's terrifying.
You wouldn't know which one to shoot at or which one to evade. That kind of sensor confusion isn't just a glitch, it is catastrophic.
It is the difference between a successful mission and a shot-down aircraft, which is why the latest info coming directly from the fighter pilots who actually have to fly these machines is incredibly blunt. They are assessing these radarless, data link-dependent F-35s as 100% non-deployable.
That phrase should send the chill down the spine of any defense planner. 100% non-deployable. So we have essentially neutered a significant portion of our own fleet.
We have.
And if you're listening to this thinking, well, we'll just keep them stateside for training and use the fully equipped jets overseas, it's not that simple, is it?
No, it's not. Keeping the stateside creates a severe degradation in overall force readiness. The military relies heavily on what they call blue versus red training.
Where blue is us and red is the adversary.
Exactly. Blue forces are our pilots practicing against red air, which mimics nations like China or Russia. If you force a pilot to practice these incredibly complex multi-ship engagements without a radar, you are actively developing bad muscle memory.
Because they are adapting to the handicap rather than training for reality.
Precisely.
Yeah.
Furthermore, the radar isn't just a sniper scope for locking onto enemy planes. It is the pilot's primary dashboard for basic survival.
What else does it do?
Well, it provides high-resolution ground mapping for navigation, it detects severe weather systems so the pilot doesn't fly into a thunderstorm, and it just provides overarching situational awareness. You simply cannot adequately train a combat aviator using a tool that physically isn't there.
Which forces us to look at the immediate geostrategic threat. Let's step back and look at the global board right now. We have peer adversaries rapidly expanding their air forces, modernizing their fleets, and aggressively posturing.
In regions like the South China Sea, yes.
Right. And right in the middle of this heightened global tension, a massive chunk of America's premier stealth fleet is flying around with lead weights in the nose. What happens if a major conflict erupts tomorrow?
The grim reality of geostrategy is that you go to war with the military you have, not the military you want. If a high-end conflict kicked off tomorrow, U.S. combatant commanders would be severely handcuffed.
Meaning they wouldn't use them at all?
Not initially. Military leadership would rely entirely on the fully equipped, radar-active F-35s. They would only authorize the deployment of these handicapped jets if the U.S. suffered significant combat losses.
Let that sink in.
Yeah, it would require our fully capable jets being actively shot down out of the sky before commanders would lower their standards enough to send these blind, ghosting-plagued F-35s into a contested environment.
That is not just an equipment shortage. That represents a tangible, calculated window of geostrategic vulnerability for the United States. And our adversaries read these same reports. They know exactly how many airframes are currently compromised.
They absolutely do.
Okay, this brings us to the $1.7 billion question. If you are sitting at the Pentagon and you know that this physical mismatch causes a massive national security vulnerability, creates ghosting errors, ruins pilot training, and leaves you open to significant combat losses, why push forward?
It's a fair question.
If you're the listener, you're probably screaming at your phone, just keep building the old APG-81 radars that actually fit the plane. If this gap causes such a massive national security vulnerability, why is the Air Force forcing this upgrade?
That is the logical reaction, but it ignores the brutal reality of modern warfare. The geostrategic payoff of the new APG-85 is simply too massive to ignore, and the older radar is quickly becoming insufficient for tomorrow's threats.
How much better is the new one, really?
Well, we have to understand what a modern radar actually does. Both of these systems are ASA radars, active electronically scanned arrays.
Which means they have thousands of tiny individual transmitter modules instead of one big spinning mechanical dish.
Exactly. And because they have thousands of modules, they can focus beams of radio energy with terrifying precision. The future of warfare is electronic. The APG-85 isn't just an eye, it is a directed energy weapon.
Wait, really? A weapon?
Yes. It can focus its radio waves so intensely that it can literally fry the circuitry of an incoming enemy missile or jam an adversary's surface-to-air radar system from hundreds of miles away.
Oh, wow. So it's about active blinding, not just passive seeing.
Yes. The APG-85, which is currently exclusive to U.S. F-35s, allows the U.S. to fundamentally deny adversaries the use of the electromagnetic spectrum. It improved weapons accuracy to a staggering degree and targets enemy airborne and surface radars at far greater ranges.
Okay, that is a massive leap.
It is. In the chessboard of global deterrence, whoever sees the enemy first and blinds them first wins. The current APG-81 is excellent, but against the next generation of stealth fighters, it might not guarantee that first look, first kill advantage.
But the APG-85 does.
Exactly. The Pentagon has decided that enduring this painful multi-year vulnerability window is the required price of admission to dominate the skies for the next 3 decades.
The juice is worth the squeeze, even if the squeeze means grounding a chunk of the fleet in the short term. But let's look at the financial friction of this transition, because the cost breakdown is incredibly revealing.
The financials are fascinating.
We are looking at a total budget of about $1.7 billion just for the retrofits. Now, if you are retrofitting one of the older Lot 17 planes, the latest info prices it at about $9.5 million per radar.
Right.
But if you were installing that exact same APG-85 radar into a brand new plane right on the production line, it only costs $8.8 million.
Yeah.
I haven't pushed back here to $700,000 just to swap a part. Are you telling me a multi-billion-dollar stealth program wasn't built with basic plug-and-play modular architecture to save taxpayer money?
It was built to be modular internally, but you are vastly underestimating the physical labor required to open up a stealth fighter. That $700,000 difference perfectly illustrates the physical friction of maintaining low observable aircraft.
Where's that extra money going?
It isn't for the radar unit itself. It is for the painstaking artisanal labor required to literally tear into the nose of an existing jet.
Because of the stealth coating.
Exactly. You can't just unscrew a panel. Maintenance crews have to carefully scrape away highly classified radar-absorbent material just to access the seams. Then they have to remove the old APG-81, modify the internal airframe to accept that new dual-mount bulkhead, install the APG-85, and then critically reapply the stealth coating.
And that has to be flawless.
It has to cure perfectly so the jet remains invisible to enemy radar. Doing that to an older airframe is a logistical nightmare. When Lockheed Martin builds it fresh on the production line, they bypass all that retrograde engineering, hence the lower cost.
It's a stark reminder that underneath all the software and digital hype, these are still physical machines made of metal, wires, and toxic chemicals.
They absolutely are.
And the timeline surrounding this physical labor is fascinating, because there is clear recognition in Washington of the geostrategic risk we are taking. The original plan had the first APG-85 fielding in January of 2029.
Right, but that changed.
Yeah, due to intense pressure from Capitol Hill, specifically Representative Rob Wittman, who chairs the House Armed Services Committee's Tactical Air and Land Forces panel. The timeline has been aggressively accelerated. They bumped it up by 9 full months to April 2028.
Which tells you everything you need to know about how seriously U.S. military planners view the current global threat landscape. 9 months in the world of defense procurement is lightning fast.
It requires moving mountains of bureaucracy.
Exactly. They recognize that every single month, a portion of the F-35 fleet is either non-deployable or flying with compromised sensor fusion, is a month where U.S. deterrence is fundamentally weakened. They are racing the clock to close this vulnerability window as fast as physically possible.
And that brings us to the ultimate takeaway from this whole deep dive. We expect these jets to be invincible. We want them to have the absolute best technology downloaded and installed the second it's invented. But you still have to deal with the physical reality of mounting brackets and center of gravity physics.
It reveals a critical paradigm shift in the future of warfare. We have entered an era where our software, our artificial intelligence, and our sensor capabilities are evolving exponentially.
Faster than we can build the planes.
Exactly. Those digital brains are permanently trapped inside the linear, slow-moving reality of airframe manufacturing. It leaves us with a profound question to consider. How do we balance the rapid, absolute necessity of dominating electronic warfare with the slow, physical constraints of our hardware?
That is the million-dollar question.
Are we entering a dangerous new era where our newest, most advanced weapons platforms become temporarily obsolete simply because the physical metal can't keep up with the speed of digital innovation?
Thank you, everyone, for listening or watching, and I invite you to listen to the other podcasts on the channel.
See you in the next one.